A few notes about computers. They're tools used to study algorithms and solve problems. They only do what they're instructed to do in the order they're instructed to do it. The level of intelligence they display is dependent upon the intelligence that we can convey through algorithms we write. It's important to note that we don't need to understand all the details of how computers work in order to use them, any more than we need to understand all the details of how a car works in order to drive one. While we don't need to know all the details of how computers work, it is helpful to have a general understanding of how they work. The basis of every modern computer is transistors and electricity. If you don't know what a transistor is, you can think of it as a switch that has exactly two states controlled by the flow of electricity, off and on. When electricity is flowing through a transistor, it's on. When there's no electricity flowing through it, it's off. Clicking the off and on button simulates the flow of electricity to a digital transistor with just two states, turning the light either off or on. Compare this to how the slider operates as an analog or continuously variable system. We use transistors in a computer to represent data and to perform operations. Transistors are the reason the size and capabilities of computers have advanced so rapidly over the years. A tremendous amount of time, energy, and money have been spent on making transistors smaller so we can fit more and more of them inside our computers. In fact, they are now so small, they're measured in what is called nanometers, and you have to use an electron microscope to see one. A nanometer is 1/1000th of a meter. To give you an idea of just how small current transistors are, consider this illustration. On the far right, we have a tennis ball, and on the far left, a single water molecule. A transistor is currently about the size of a single antibody cell. That's almost 10 times smaller than a single virus cell, and they're being made smaller all the time. Since transistors are so tiny, popular computers now contain billions of them.